for a while. However, there's always a little bit of mystery about what cloud is. So we're going to have a cloud expert from Cadence to demystify the cloud today. We have Craig Johnson, who is a VP of Cloud Business Development for Cadence Design System, who joined Cadence from 2004. And prior to that, Craig has 11 years experience at Intel. So today, let's welcome Craig.
All right, good afternoon. It's a pleasure to be here. I'm happy to be able to come to CASPA and talk a little bit about semiconductor design in the cloud. I thought I'd try to answer 3 questions today. Some of these you might already think you know the answer to, which is good. Other cases it might surprise you. But what exactly is the cloud? How will it impact semiconductor design, and what is it that Cadence is doing? So let me start with that first question. So in the course of talking to our customers about the cloud, it's quite interesting in that for the first few months that we did this, I would go out and we would start immediately talking about the cloud solution. And we inevitably discovered that there was a communication gap, that what I was calling the cloud was not exactly what the other person was thinking of as the cloud. And I'll give you a real example of this. This is true. So on Friday, I was getting a haircut, and it was a new barber, and he was about to cut the top of my hair, and he asked me, "Do you like it short?" And I said, "No. This is what he doesn't think is short." There's a communication gap, right? So it's what is your frame of reference, and that's really what we have to figure out when we talk about the cloud. So I have a little way of simplifying this. As a technologist, it's easy to ignore all of the hype and the wording around it. So really, the cloud, if you want to get it straight, it's just a fog machine in a data center. It's nothing more. There's no magic technology. There's nothing mysterious about it. This is just IT technology that's got some new names around it. But it's important to understand and to be clear on what we mean. So I have a little diagram that I like to use to make sure that we're talking about the same thing. If the user is interested in bringing software with them, meaning they either own the software or they're going to bring licenses from another provider, but they want to rent hardware, what they really want is infrastructure as a service. And you'll hear this called IaaS. It comes from AWS, from Azure, from Google, from Alibaba. There's a lot of different companies. If instead the desire is not just to bring software, but to actually create the software or deploy a service, and they want to do that from the cloud, that's what we call a platform as a service. And a lot of those same vendors that sell infrastructure as a service also offer platform as a service. In addition, there's other companies that don't have as their core business infrastructure as a service that provide platforms as a service. For example, Salesforce has a platform like this. And finally, some users only want to use a service and manage only their own. They don't want to manage the software, they don't want to manage the infrastructure, and that's what we call software as a service. And some of the same providers are present in multiple layers. Companies like Workday for HR, Salesforce for CRM, and ServiceNow for IT ticketing. So all of that comes together as the cloud. So when someone asks me what's the cloud, I always have to figure out what do you mean by cloud? Are you talking about infrastructure, platform, or quote service? So let's look at a little bit of the data behind this. And this is remarkable growth that's occurred. And this is generically across all of the cloud data from Gartner. It's probably could be updated, but it wouldn't look any different. All the graphs will start small on the left and they'll be big on the right. But this is amazing. Here we are halfway through this projection, and the cumulative value of this is now more than 160, or will be more than 162 billion in just 2 years. You can see the relative scale of these things, and infrastructure as a service in particular continues to grow very, very fast, even though that's a very, very large segment. And this is why there's a lot of enthusiasm behind cloud. It's becoming a baseline for many, many other applications. Here's a list of some of the the major providers. Now this is also a little bit dated. I didn't get newer data than this, but it gives you a sense of the growth. So if you look at these top providers, anywhere from 45% annualized growth all the way up to 127% for Alibaba. So a tremendous amount of growth given the size of this. And if you look at that in terms of market share, Amazon is by far the largest. So they defined this segment. They continue to move very, very quickly, and others are largely catching up from a business perspective. What's a little bit surprising, though, is that these small little slivers are very, very large. I know that Google last year announced they did $1 billion in cloud, and I think Alibaba said they continue to grow at the same rate. Amazon just announced a $5 billion quarter, so this is, you can see that this has continued to explode. A lot of excitement. Now, what about China? Just one slide on China, and that area is still developing. It's growing quite rapidly, like it is in other parts of the world. The leaders are a little bit different, right? So you've got Alibaba as the current leader, and that's forecasted to continue to be the case. But other companies like Tencent and Huawei are anticipated to close that gap and be the leaders out here in the next few years. One of the things that's a little bit different is China has these local ownership laws, and that means that these non-native providers have to partner in a particular way, and in some cases that's not growing as fast. There's also political uncertainties sometimes that create a little bit of concern. There's IP protection concerns, and everyone is very sensitive about where their data lies. A little different in China than in the West. The cloud in the rest of the world was largely driven out of the B2B kind of use cases. The e-commerce, the back end of that, these CRM systems, all of these large enterprise applications tended to drive it. Whereas in China, we saw quite a bit more around consumer things. So this could be chat or gaming or those types of things. So there's a huge untapped potential, in China for this to continue to grow as there is in other parts of the world. I'm sure that many of you here know way more about the cloud in China than I do, so I would defer to your expertise in that regard. So that's what the cloud is at a high level. Now, why is it important to semiconductors? Well, most of us who have lived through the semis over the last year can almost, in every given year, you can write a list of impossible challenges that we face collectively as an industry, and this is just a tiny fraction of those. There's always the next process node or two process nodes ahead. No one even knows how we're going to make it work, and then 5 years from now we look back and think, oh, those were the easy problems. The hard ones are the ones that are coming up at the next node. And so all of this boils down to a tremendous amount of complexity, a lot of extra data that's being created. And what hasn't changed is the calendar for when these products need to be delivered. So things become 4 times as complex. You don't have 4 times as long to deliver that product, and that creates a challenge. An interesting example, multi-patterning, for example. A few years ago, the thought was that 193 nanometer technology would be a thing of the past by the time that we got to where we are. Not only is it not gone, it's still part of the future roadmap. And in addition to it, we're now selectively applying new technologies to make that patterning even more complex, and there's more versions of it. So you could do this for every single one of these, and cloud can be a way to address some of this complexity. Traditionally, when people are designing semiconductors, they have this graph that they have to deal with, and if the red line, you can think of that as the compute demand that they have at any given time, and the green is how much they have available in their on-site data centers. So whenever there's a gap, like in the case where the red line's above the green, that means your engineers could be waiting for hardware. On the other occasions where the engineers are fully engaged engaged, you still might have idle equipment, which isn't financially very efficient. Or when by the time you realize you need more capacity, you might have a project delay because you're waiting for this to happen. And so all of these things have been challenges in the traditional data center model. So what do we do? Well, I think it's a chance to rethink the rules. So if we think about how semiconductor design was traditionally constrained, we always thought of compute capacity as a fixed and limited resource. To buy more servers and to increase all the networking requirements, that required capital, and capital budgets tended to be fixed. Those are harder to get dollars out of your CFO than almost any other type of dollar. There's competition for resources, so one engineering team hits some sort of critical time frame and they need more hardware than one of their alternative teams, and that means zero-sum game. One team gets more, someone gets less. Software, for the most part, and this is true of EDA, was largely written to be single-threaded or take advantage of a very low number of CPUs. It was 1 to 4 CPUs seemed to be all that was really needed. And then IP almost always had to stay in-house. And this is something that for the last 4 or 5 years, as I've worked in and around the cloud, we've had most of the conversations with customers would be about IP. So the neat thing about the cloud is that it's a chance to change all those rules. So now there's unlimited server capacity available. You can buy that with operational dollars, not capital dollars, and you can grab those from many, many places within the company when the peak is required. It doesn't eliminate the cost of the environment, but it gives you more flexibility. And then resources aren't in the same form of contention. Companies like Cadence have spent a tremendous amount of our R&D investment to parallelize our software, and I'll show you a few examples of that. And also to have models that are more friendly to that sort of compute approach. And I would say that we've finally hit an inflection point within the semiconductor industry where more of the semi companies are comfortable with putting their IP into the cloud than ever before. So all of those things mean that it's probably now time to see the cloud play a serious role in the creation of semiconductors. So it's a mega trend outside of semis, so semi can benefit from the investments that are being made by all these other industries. There's a lot of productivity to be gained by doing this. Can shorten a design cycle. You can scale things in a totally different way. You can bring business flexibility and technical flexibility, and finally the security. So we think it's too compelling to ignore now, and we're going to see this as the next big wave. The other thing that's critical, and this just happened a few weeks ago at DAC when we announced our formal cloud offerings, a company like TSMC, which is among the most conservative with their IP, and they're very protective of their files, has spent a lot of time with us, and they've audited from a security perspective our procedures and how we protect and handle data, access to the cloud, who gets into the cloud, who can see it, and by virtue of that, they're now comfortable and have given us this endorsement that if we have a mutual customer that wants to use the cloud, we can do that now, and that just requires a little bit of paperwork. But that's a big change in the ecosystem, and we think this will be another point of acceleration of the cloud. Okay, so how can Cadence help? I'll give you a little overview of what it is we're doing. We have actually been working on the cloud for call it at least 10 years here. And our roots go way back to some technology that we developed to assist our customers in debugging problems that they have or performing services engagements. And so we had this thing that was called virtual CAD or VCAD that we, in 2008, turned into a business that we called hosted design solutions. And so it was very much a cloud-like experience, except that information was all being hosted at Cadence, and we had investments in data centers around the world that we would host these projects. Along about 2011, we internally, for business purpose, started adopting a lot of these SaaS applications. We began industry engagements with, in conjunction with some of the cloud providers, as well as talking with our customers. We architected new features into our products, and that's a multi-year effort, and that's still ongoing. We began using the cloud internally to develop our software, and that required us to figure out the IT complexities and how to make that happen. And beginning last year, we had a lot of customer engagements and began selling some of our cloud offerings extensively. And finally, just last month at DAC, we announced our full portfolio. So that's how we got to where we are today, to have sort of that depth of offering that I'll just give you a high-level view. Many of the conversations that we have are with semiconductor companies who are trying to decide how they want to utilize the cloud. So we have a simple one-pager to explain it, and we ask them first, think about what your priorities are. You can go to the cloud for many reasons, and you need to have that clear in your mind so that you optimize for the right variables. You have to figure out what the use model is that makes the most sense, and by use model we mean, is the cloud your baseline environment, or are you only going to use it for peaks? If you're going to use it for peaks, what sorts of functions do you want to use it for? Is it for simulation? Is it for layout? Where does it make sense? Once the company has that idea, we ask them to collaborate, and that collaboration has to cut across many partners. It's not just Cadence as a tool provider, but it includes the cloud vendors, their IP providers, and the foundries. So all of these parties have to sort of understand what's going to happen with these projects as they move to the cloud. And that ultimately allows someone to build a plan. And what we find is that most companies are most comfortable identifying a specific small-scale project to begin with, and that project is consistent with their bigger objective, but it's something that they don't want to. Typically, you don't want to make a huge, risky investment before you have some experience with it. So we do a lot of these sort of starter engagements. One thing on use model. This is actually an overview of what we announced. What was interesting about it is we announced our portfolio, but we did so with additional endorsements from Google, Amazon, and Microsoft. And those are pretty big partners for a company like Cadence, when we feel like we're a pretty big fish in EDA, but we're quite small in comparison to the scale of these other partners. And it's evidence of how interested those cloud companies are in servicing the semi industry. There's a tremendous amount of compute requirement that is generated by semiconductor design, and that's all of these providers want to be a part of that. Our portfolio is laid out in a sort of simple way. We first ask a customer whether they want our help or not. If they want to utilize our help, that's a Cadence Managed solution. If they would like to do it themselves with their own IT, that's a customer managed solution. And so for our customer managed clients, we have a model we call the passport. So it's a cloud passport. It gives them the ability to take certain software that we've enhanced and tested for the cloud, and they can run that in Google, Microsoft, or Amazon. And there's a few examples here of what that looks like. So here are a couple of product categories, like physical verification, extraction, timing analysis, and these other sorts of things that are highly compute intensive can utilize the benefit of that. And what we've done as part of our re-architecture is scaled it so that now instead of using 1 or 4 CPUs, it can use 1,000 or 1,500. And all of that enables new use cases to emerge in terms of how the design gets accomplished, so we can start to impact the design time. So that's the Cloud Passport. From a Cadence Managed standpoint, we've got an offering that we call the Cloud Hosted Design Solution. So this is where Cadence takes the lead and is the customer's sole interface for the project or for their design environment. And we have ported that to run in Amazon and Azure. So no longer in a Cadence environment. This is now in a public cloud scenario, and they're able to take advantage of the scale of the cloud, no longer constrained by what we invest in. We've got some additional technology that we announced in our rolling out that's portal-based. The difference here is that we find that many customers just want a cloud, or we speculate they want a cloud for shorter periods of time than to do their whole environment. And this portal is a browser-based way of having design tools delivered and ready to use. And finally, we built a cloud out of our Palladium emulation system. So those who follow design know that simulating these designs takes a long, long time. And even if you put the highest performance servers to work for you, it's still not fast enough to emulate the chip at a full chip level. And our Palladium platform is a specialized supercomputer that does this very, very effectively. We've taken those and we've put them into a professionally managed facility, and now we sell access to that capacity for smaller periods of time. So you don't have to buy a whole machine to get the benefits of doing emulation. And that's all part of our larger umbrella here. So just in conclusion, we think this is a great way to improve productivity. You can, with the work from your IT group, if you're doing this, you can get resources now in minutes instead of a month-long procurement cycle and installation process. You can turn around designs faster. You're more efficiently using resources. One thing that's sometimes not appreciated about the cloud is that you don't just have massive scale. You've got the scale that's exactly appropriate for what you need. You think of this as, a given piece of software may need 16 gigabytes of memory. Another one might need 500. Now you can buy exactly that amount of memory in the instance type that you're using, and if you have your own data center, you typically buy whatever the largest configuration is in case you need that, and so you get more efficient scaling in that regard and can save a little bit of money. Security is always important, and flexibility. So for us, flexibility is a combination of let the customer do what they want, but also choose the model that they want. The reason that we didn't just have a Cadence Cloud-hosted solution that was just monolithic is that we knew that many, many different use cases were of interest. So if I were to summarize all this back on my original diagram, what Cadence is doing, so if your interest is to use our software, deploy it by yourself, and figure out how to run your environment, then that's what this Cloud Passport's for. We don't have any offering for platform as a service, and that, as you can imagine, is because we're not trying to build a new platform for you to develop EDA tools. I think that's that decision as an industry was made 15 or 25 years ago when all of these EDA companies emerged. And then finally, if their interest is only to manage a service and they don't want to get involved in the configuring of a cloud or the software, they should pick one of these Cadence Managed solutions. So that's the big picture. Hopefully I was able to answer portions of these questions that are out there. Happy to talk in more detail elsewise. But ultimately, we think the cloud for semiconductor design is here, and we're excited for the future it portends. So, thank you very much for your time.
Very good opportunity to demystify the cloud. Yeah. So we're going to show our appreciations for our president. We're going to have a flag presented by President Brandon.
All right.
Yeah.
We're going right here. Get one for my kids.